Hey guys, Mr. Backerwork here. In this video, we're going to focus on writing linear equations in point-slope form. Now remember, when we're using point-slope form, we're looking at an equation being written out in the form y minus y1 equals m times x minus x1. And we want to remember that m stands for the slope of our line, and the x1 and y1 values come from some ordered pair, some point that we're working with. So as we look at this first example, we want to write out an equation for a line that passes through the points negative 2, 5 and 2, negative 1. Now as we're writing things in point-slope form, we need to have a point that we're working with. And we actually have 2 points. I'll talk about how we're going to deal with that in just a second here. But then we also have to have a slope. And right now we don't know what the slope of our line is. But we do have a slope formula that goes y2 minus y1 over x2 minus x1. So I can use these two ordered pairs that I've got, these 2 points that I've got, to find the slope of this line. So this first point, the negative 2, 5, I'm going to call that my x1 and my y1. And this other point, the 2, negative 1, I'm going to call that x2 and y2. Now I like to label those so that as I'm plugging them into my slope formula, I get the numbers plugged into the right spots. So my y2 value is negative 1. Minus my y1 value is 5, over my x2 value is 2, minus my x1 value, which is negative 2. So across the top, negative 1 minus 5 is negative 6. And then across the bottom, 2 minus negative 2, we've got a double negative happening down there, so we're going to switch that into addition. So now 2 plus 2 is 4. Now we've got the fraction negative 6 over 4 that is reducible. Each one of these numbers is divisible by 2, so we would get negative 3 halves as our slope. So now that we have our slope, we also need a point to work with. And we have 2 points, and I said I was going to talk about how we would deal with that in just a second. You're actually allowed to use either one of these points and you'll get the exact same answer. What I'm going to do is pick this first point, the negative 2, 5, because I already have that labeled as x1 and y1, and in my point slope formula it has x1 and y1 in it, but I will show you that both points will give you the exact same answer. So if I use the first point, that would be y minus 5 equals that slope of negative 3 halves times x minus negative 2. So I'm going to work through this one first, and then we'll do it using the other point again to prove that we would get the exact same answer. So inside of this parentheses, we've got this double negative happening, x minus negative 2. So I'm going to switch that over into addition. Now we are going to clean this up to get it in slope-intercept y equals mx plus b form, and we're going to start by distributing that negative 3 halves on the right-hand side. So if I take negative 3 halves times x, that's just going to be negative 3 halves x. If I take negative 3 halves times 2, well, I'm going to put this 2 over 1 so that we can see the fractions happening in here. On top, negative 3 times 2 is negative 6, and on bottom, 2 times 1 is 2, but this fraction is reducible. So we would end up getting negative 3 halves x minus 3. Now we haven't done anything on the left-hand side yet, so that's still y minus 5. But remember, our goal is to get this written in y equals mx plus b form. So I'm going to add that 5 over to the right-hand side. So the minus 5 and the plus 5 cancel each other out, so we get y equals. On the right-hand side, we still have the negative 3 halves x, but now we need to take the negative 3 and add 5 to that, so we would get plus 2. So we get the equation y equals negative 3 halves x plus 2. Now I said I was going to show you that we would get the exact same answer when we use the other point as well. So I'm going to scroll back up here so we can see our point slope form. So it's y minus the y value. I'm going to use this 2, negative 1 point now. So the y value there is negative 1 equals the negative 3 halves slope times x minus the x value from the point 2. And when we go through and simplify this down, we should get the exact same answer as before. On the left-hand side, we have a double negative to clean up, so I'm going to turn that into addition. On the right-hand side, I'm going to go ahead and distribute that negative 3 halves. So negative 3 halves times x is negative 3 halves x. Negative 3 halves times negative 2, I'm going to put the negative 2 over 1. So negative 3 times negative 2 is positive 6, and then 2 times 1 on bottom is 2. And again, this fraction is reducible, kind of like we saw as we were working our way through the other example. 6 divided by 2 is going to be 3. On the left-hand side, we still have the y plus 1, but our goal is to get y alone, so we're going to subtract the 1 from each side of our equation. So we get y equals negative 3/2 x plus 2. Now, typically, it's not necessary to do both cases using both of the ordered pairs. I just wanted to show you that you would get the exact same answer regardless of which point you chose to work with. So here's another example where we want to write out an equation using 2 points. So this line passes through the points 3, 0 and 2, negative 4. We're going to use that point slope form again. So y minus y1 equals m times x minus x1. We need a point and we need a slope. We have 2 points, so again, later on, we're just going to choose one to work with. We do need to find the slope using our slope formula. So remember, slope formula is y2 minus y1 over x2 minus x1. I'm going to label my ordered pairs to make sure I get the numbers plugged into the right spots. So the first point is x1 and y1. The second point is x2 and y2. So when I'm doing the slope, I would take negative 4 minus 0 over 2 minus 3. Now on top, if we take negative 4 and subtract nothing from it, we're going to get negative 4. On bottom, 2 minus 3 is negative 1. Now we can reduce this down. Negative 4 divided by negative 1 is just going to give us positive 4 as an answer. So the slope is 4. Now we need to pick one of our points to work with. I'm going to choose this first point here, this 3, 0. Anytime you have a point with a 0 in it, 0 is always a nice number to work with, so we try to use that if we can. So on the left-hand side, this would be y minus the y1 value, which is 0, equals the slope that we just found earlier, 4 times x minus the x1 value of 3. Now we're going to do some distributive property on the right-hand side. 4 times x is 4x. 4 times negative 3 is negative 12. On the left-hand side, if we take y and we subtract nothing from it, that minus 0 kind of just drops out of there. We don't need it in there, so we just get y equals. Our goal is to end up with a y equals mx plus b equation, and we just did, so there's no more work that we need to do with this one. So we just get the equation y equals 4x minus 12. Now I will remind you that we could have chosen to use the other point. We could have used the 2, negative 4 point to plug into our point slope form, and we would have gotten the exact same answer. So it doesn't matter which point you choose when you're using point slope form with 2 points. That's going to be it for this video. Thanks for watching.